All right, now we're going to work through quickly a couple of problems, help you again get more familiar with the normal distribution and in the context of a scenario, if you will, a practical situation. And again, as before, you've seen this chart. Our process is going to be, we're going to define our random variable. We're going to identify the probability distribution, identify the parameters of the random variable, and again, in this case, the mean and standard deviation. We're going to express the problem in terms of a probability statement, and then we're going to transform the probability statement into that probability mass function, or a cumulative distribution function. And in this case, we're going to use the transformation, the Z transformation, so that we can apply the cumulative distribution function, substitute the parameters, calculate the solution value, which you can do on the calculator or look up in the table, and then we're going to answer the question. So let's dive into one problem with two different questions. So the example problem that we're going to look at is the life of a battery is normally distributed with a mean of 500 days and a variance of 2,500 days. So again, right off the bat, we to use our tool, we want to define the random variable. So the random variable in this particular case is the lifetime of a battery. And it doesn't matter what you call that, we can call it X, but just to be different, let's say L is going to be the, if I can type this in there, L is the lifetime of the battery. And we're going to lifetime in terms of how many days the battery operates, or you could say the number of days the battery operates. So that's defining our random variable. Our probability distribution, of course, is the normal distribution that's given to you in the problem. Identify the parameters, and of course, for this particular problem, the mean is 500 days. I'm just going to put D. And the variance, notice we're given the variance, and what we really want to have is the standard deviation. But the standard deviation is the square root of the variance. And so in this case, that's the square root of 2,500. And so we know that our standard deviation is 50 days. All right. So what we want to know is what fraction of these batteries will survive on 580 days. And then the second question is what fraction will fail before 430 days. And you might think that the days is countable, but we're not. We actually can measure this in terms of partial days as well. So this is going to be considered a continuous random variable, not a discrete. And again, when we say the word fraction here, that's just another way of saying what's the percentage, or again, what's the probability. And so now we want to let's express this first question in terms of what's the probability. So first of all, we want to express that in terms of a mathematical relationship, which we want to find the probability that the lifetime of the battery in days is greater than or equal to 580 days. And that's our probability statement. And then this one is we want to find the fraction or the probability that the lifetime is less than or equal to 430 days. So those are the probability statements that correspond to these questions, and that's what we're going to try to determine next. So the first one we're going to work is problem A, and let's look at this example. All right, and again, we've just drawn out the a diagram, and so what we want to know is what's the chance, what fraction will survive beyond 580, which is the probability. Again, I'm going to re-express this, that our lifetime is greater than or equal to 580 days. Now, again, this is our, hopefully you'll realize this is our X value, or if you will, L value. And the 580 days is out beyond 500 days, which is our mean. So somewhere out here to the right is 580 days. And if the lifetime is greater than or equal to 580 days, then that's everything, this little small area, everything to the right of 580 days. So this is the area that corresponds to our probability, and that's what we want to have. That's what we want to have answered. Okay, so how are we going to do that? Well, we're going to use you can use your calculator, but what we're going to do is we're going to use our Z transformation. Let me get this back here, 580. And we're going to calculate the value of Z for this particular situation. All right, and so we know that Z equals, this is a Z, X minus mu over the standard deviation. Right? And we know all of these values now because we want to find 580. We want to find which is 580 minus the value for the mean, which is 500. Again, that gives us a positive value in the numerator. And this is going to be divided by our standard deviation, which is 50. And of course, this equals to the subtraction. This is 80, positive 80 divided by 50, which is 1.60, which is our value for Z. So remember this value, 1.60. Now, again, and we want to find everything that's to the right of anything that's area under the curve that's to the right of 580. So let's go to our table of the normal distribution. And again, we're looking for the Z value that corresponds to 1.6. Remember, our Z value equals positive 1.6. But let's see, that here we got here is 1.6 and it's 1.60. So this is the 0.9452. Now, you need to remember that this table, the blue, remember, corresponds to the table values correspond to everything that's below positive 1.60. So what we need, excuse me, to answer our question is everything that's above this value of 1.60. We don't need the blue area, we need this white area that's above that Z value. And so in order to do that, we're going to calculate the complement of that value. And so we know the complement of that is 1 minus and our value of 0. We read from the table 1.9452. And so this value, this probability that we're trying to find is 0.05. That's a 0, not an 8. 0, excuse me, 5, 4, 8. And this is our answer for the probability. So there's a 5.5% chance that this battery will live beyond 580 days. All right. So now let's look at question B. We want to know what proportion or what fraction of these batteries will fail before 430 days. And thankfully, none of our parameters have changed. And we want to find, now in this case, somewhere out here to the left is the value below 500, which is 430. And we want to find the Z value that corresponds to 430. So let's do that arithmetic. We know that Z equals X minus mu, and our X again is 430. And the mean again is 500. And our standard deviation is 50. Now and I did earlier, but let's re-express this. We want to calculate the probability that our lifetime is less than or equal to 430. Okay, and so if we do the, excuse me, the arithmetic, the numerator is going to be minus 70 divided by 50. And it needs to be minus because this is left of the mean. And this is going to be negative, the Z value negative 1.40. All right, now before we go to the table, let's remember this is the area to the left, less than 400, that we want to calculate. Let's think about this before we go to the table, because the table value is going to only give you everything. First of all, it only has positive value. So what we're going to see in the table is the value for Z that corresponds to positive 1.40. And that value, that the probability that you'll calculate is in that table is everything that's to the left of 1.40, positive 1.40. But that's not what we want. For our answer, we want to know this area that's, because of the symmetry, we want to know this area, this green area that's above that point. And hopefully you can make the connection here. I'm going to try to pick a different color. That this area, because of symmetry, in this area are exactly equal. And so that's how we can use this positive table to find this area. And what we're going to do is actually find this area, but because of symmetry, we know that this area and this area are going to be, under the curve, are going to be exactly the same. So let's see how that works. So now we're going to go to our table again, same table. We're going to look for the Z value of positive 1.4, not negative, but positive 1.40. And of course, that's 1.40 is right next to it. So the value that corresponds, everything now to the left is, in this particular example, the positive 1.40 is 0.09192. But we know that's everything over here. Again, the area that corresponds is this area to the right, which is 1 minus. And so again, we're going to go and find our probability is going to be 1 minus 0.9192. And doing the arithmetic, doing the subtraction, that's 0.0808. 0.8008. So just 8%, a little bit more than 8% will fail before 430 days. So all of this is summarized on the next table, next chart. And again, as you can see, the green area to the right here is what we calculated is where the batteries live more than 580 days, and the area to the left of 430 here, this is an 8% chance of the battery life. So as another question that's not included, if I were to ask you this, what's the probability that the battery survives between 430 and 580 days? And hopefully you could get this. Let's take a look at this. The probability. What's the probability that the lifetime is greater than 430 days, but is less than 580 days? And actually, hopefully you can understand that what area does that probability correspond to? If the lifetime is between 430 and 580 days, then that probability is going to be everything between these two values, between these 2 points. And you've already done all of this work, because it's going to be all of this area between these 2 points. And so it's everything but the sum of these, it's everything but the sum of those that fail before and those that live beyond. So it would be, we're going to calculate this by 1 minus 0.0808 plus 548. And so that's going to be 1 minus 0.1356, and that's going to be 0.8644. So there's a little bit more than 86% chance that the battery its lifetime will live 430, but not beyond 580. So hopefully that, if you have any questions about that, again, please let me know, and happy to work through this with you.